I'm going to create a new notebook, and my objective is to show you the random numbers available in Python. So primarily, I will use one with the default library that generates one random number at a time, and then I will use the random number library from numpy. So this is the IPython notebook. Let me suggest a name. So, and this is from the Google's web server. Only the active internet connection is required. So we do have the active internet connection. So I say it is random numbers, right? So I add a text thing just for a title, for the sake of title. So here I can write as a title random numbers in Python. So first thing, with the default library, and this is important and imperative to recognize that this type of random number is available in all programming languages. So the default library is the import random as random, right? So I'm going to use the full name in my commands. So with this random number, generally I import the libraries in a separate code segment. And I write the rest of the commands in the other. So this command is legal, right? Since no error has been prompted by the computer. So I can call it say random dot. So I have several options to call. So there is a random number built-in function or method. There is beta variate, there is choice, expo variate, maybe for exponential distribution. Then there is Gauss for Gaussian distribution. There is log normal variation. So random numbers of different flavors can be generated. They can conform to many different kinds of distribution. By the way, in this course, in this demonstration, I'm going to use the random, simple random. So what it is going to generate? It will generate one random number. If you call this one again, so this is a slightly different number, right? If I like to call several random numbers, so I have to use, I have to write a loop. So we know for I in range, say 5, and I say x equals random dot random. And this is the end of the loop. Well, I haven't used any print command, so I can say print x equals, without any formatting, I'm going to write here I at the title, I equals I, and then I write here, okay, just for the sake of title. Okay. So let's run it. So for I, several values of I, the one random number at each execution that was generated. We know the index in Python runs from 0 to 4, which is similar to the convention, programming convention in C language. So you can use one random number at a time, right? To see the details of this function, how it is written, so you can either look for the Python documentation from the web or from your installed Python. But I'm more interested in the random numbers available in from numpy library, and I will generate their distribution. So import the libraries. Let me improve the view. Yes, this is better. If you look for the random numbers, default random numbers are generated between 0 and 1, right? So I import the library, import numpy as np, which is the standard way of doing it, and matplotlib.py plot as plt. So from numpy, there is a sub library which is random. So for example, let's say y equals numpy random dot random, and I say 5. So it is going to generate 5 random numbers. Okay, we can read the documentation. It returns a random floats in half open interval from 0 to 1. Right? 1 is not included in the random number set. Okay, so you can see the rest of the thing. So y equal 5, y equal to numpy random dot random. So 5 random numbers will be returned. So a vector of 5 random numbers is there as y, right? And if you like to have a random number between, say for example, x, yes, if you just write x, so it will generate the value. Print command is not necessary, right? So all the variables which are available in your program, you can call those variables at any time just by writing their variable, right? So here at the next level, at this level, let me generate the random numbers, random dot rand. Okay, this is also justified. It is for the same random number distribution. So I say 5 random numbers between 2 and 7. So the random numbers primarily which were to conform a range of 0 and 1, now they will be between 2 to 7. Oh, I didn't print that, but this is available. So I can call it. So the array has been generated x. So you can notice the values, they are between this has been generated several times, 10 times. So maybe the command has not been written properly. It has taken it as a matrix. Let's learn from the experiment. If you like to see what has been generated or stored in the computer, so you may click at this X. So it will show you the types of the. It will show you the type of the variable. So X is an n-dimensional array. So the array it has generated, it has a shape of 10 rows, 2 columns, and 7 layers, right? So it has generated 7 10 cross 2 matrices of random numbers. So it means I have not used the command properly, right? So that is something also for learning. Let me try another. So numpy random dot random. So my objective to generate say 10 random numbers in structure of say between 2 to 7, right? There is some error. Takes one positional argument, 3 are given. देख लेते हैं. X numpy random dot random, and I say okay 2 to 7. सिर्फ इसको देखते हैं. No, this is not allowed. This is correct up to this point. And you have to write the X. Okay, let's justify first of my claim. I said the random numbers are uniform between 0 and 1. So how to test that? For example, now I generate an array numpy random dot random. So I generate say 1000 random numbers, right? Distribution of random numbers. So the process is that I will create certain levels of X values and see how many values fall within one interval, right? So for doing that, I have this command numpy dot histogram. So I say X and divide that into 10 limits of X values, 10 classes, right? Well, this function is going to give me just the values. Not the graph. So I have the count values. So count values, frequency values, 99 in the first class, 95 in the second class, 100. Well, I divided that into 10 classes. So if I say from 0 to 0.1, so out of 1000, how many values should be there? If it is a uniform thing, there should be 99 around 100 values, right? From 0 to 0.1, then from 0.1 to 0.2, 0.2 to 0.3. So these are the values, right? So the other option to see the distribution and with the graph, so I can say lt dot hist, this is function X, and develop 10 classes in 10 classes and develop a graph. So this is the frequency distribution of values. This is not a well-known distribution. It seems to be. So it means let's improve the number of particles. Second जो है x की लिमिट्स का है, क्लास लिमिट्स का है, ठीक है? ये आपने अच्छी बात की, इसलिए हमें यूं लिखना इसको यूं चाहिए x is equal to, for example, बल्कि और आसान जेनेरिक प्रोग्राम करते हैं, n equal to say 10,000 और यहाँ पर लिखेंगे हम x equal to numpy random dot random and particles generate करें. The first array was of frequency. So let's fix the nomenclature fx x limits, right? कभी x limits और तीसरा एक जो है वो इसके अंदर ये ग्राफ को के साथ अटैच करने के लिए हम ये वर्ड पैच यूज कर लेते हैं. और यहाँ पर अगर चाहें तो कलर्स भी दे दें, कलर इज इक्वल टू रेड। और भी बहुत सारे एट्रीब्यूट्स इसमें दिए जा सकते हैं। मैंने अब नंबर ऑफ पार्टिकल्स को ज्यादा किया, सो द डिस्ट्रीब्यूशन इज विजिबल। कुछ और ज्यादा कर लूं, raised to the power 5 particles. We are moving towards Avogadro's number. So this is the distribution. So at least at academic level, your calculation should start at this level. At this level, these random numbers are uniformly distributed. So the first base random number generator is a uniformly distributed random number, right? Uniformly distributed random numbers. मैं इसे यहाँ से एक करता हूँ कि इसे मैंने 50 कर दिया और यहाँ पर ये 10 ही है, इनको हम बिन्स कहते हैं। तो मैं इसे लिखता हूँ n bins equal to 20. So now I'm making it more generic. So number of particles and number of bins are generic. So I say n bins. Red color is an indication of horror. So we should avoid red color, at least in academics. So this is a uniformly distributed random numbers. I have given the proof that the random numbers generated by computer at the base level, the first generator is to generate uniformly distributed random numbers. अब इसमें एक और चीज मैं करता हूँ कि instead of random library, I am going to use the other routine. So I say norm. Is norm available? Normal is available. So n random numbers, the normal distribution comes with the characteristic mean value and a standard deviation. So let's use the generic distribution 0 to 1. And now let's see the distribution shape. This is not the normal distribution. No. Okay, let's stop at this point.